Hi, welcome to another video in my series on solving fractional inequalities, where we're dealing with an inequality that has got some modulus function in it. Now in this example we've got 5 over the mod of x minus 3 is greater than 2. And what I've suggested in the past that we do a graphical method for questions like this. What I can't do though is, in this example, is multiply both sides by the mod of x minus 3, because it is going to be negative for some values of x. And that would mean that it would affect the inequality sign. It would need to be reversed on occasions. So in this example, I'm going to draw the graph of y equals 5 over the mod of x minus 3, and also the graph of y equals 2, and then compare them. Now for the graph of 5 over the mod of x minus 3, if I was to take away the mod sign and just look at sketching the graph of y equals 5 over x minus 3, then this is a reciprocal based graph. I know that if it was 1 over x, it would be a graph like this. But because it is x minus 3, it's going to cause this graph to move to the right 3 units. So there's going to be an asymptote at x equals 3. Let's just draw a line down there, okay, and we'll put in that that's at x equals 3. So our reciprocal graph of 1 over x, okay, like this, would now be slid across to the right by 3 units. So it's going to look like this and look like this. But then we're multiplying it by 5, so it's going to be stretched parallel to the y-axis by scale factor 5. But essentially it's still going to retain much the same kind of shape. So if I sketch this in, we're going to get our graph looking something like this. And then it's going to be on this side as well. But before I just jump in and sketch this part of the curve, because it's got a mod sign in it, then what I can see is that when I take negative values of x, like when x is minus 1, I'm going to really be plotting at the point where x is minus 1 exactly what I would have got when x was 1. Because the mod of minus 1 is 1. So I know that this curve would have come up like this, just normally, and gone across like this. But because I've got a mod sign in it, any negative values are going to replicate what you see on the right hand side of the y-axis. So our graph would have come up like so, crossed the y-axis when x was 0, but now we're going to get a reflection of the right hand side of the graph in the y-axis. So that means that there's going to be an asymptote at negative 3. So we'll just put that in there, that's at negative 3. So our graph would come across to the y-axis and then drop away back down again to that asymptote x equals minus 3. And then as for this part here, when you've got values of x greater than 3, we had this branch of the curve, but now when you've got values of x less than minus 3, we're going to get our curve looking something like this. Let's just finish off that x-axis across there. Try it out with those values of x. Take a value of, say, x equals 4, put it in here, 5 over 4 minus 3, 5 over 1, which is 5. When you look at minus 4 here, 5 over the mod of minus 4 would have been 5 over 4 here, minus 3. Still 5 over 1. So therefore you'd have got 5. So hopefully that shows you that you're going to get a reflection then in the y-axis. Now we just need to draw the graph of y equals 2. And y equals 2 will be a graph something like that. Let's just mark that in then as y equals 2. So when it comes to solving this inequality, then in the usual way, we're looking for where this graph, which is the red graph, is greater than the blue graph, y equals 2. Greater than meaning for what values of x is the red graph above the blue graph. And I can see that that would be, if we were to take this point here, let's call it A, and this point here, let's call it B, that those values of x that we require will be from A to the dotted line here, the asymptote, x equals minus 3, and from this asymptote, where x is 3, up to the point B. So I need these points A and B, the points of intersection. So for A and B, what I would need to work out then is where 5 over x minus 3, by the way, I should really put that in as a mod now, okay, 5 over the mod of x minus 3. But what I can do is just equate these two together. So I can just say then 5 over x minus 3 equals 2. And I'm going to rely on the symmetries of the graph to find out A and B. So if I multiply both sides by x minus 3, I get 5 equals 2 times x minus 3. Expand the bracket out and you've got 5 equals 2x minus 6. Add 6 to both sides and you get 11 equals 2x, and now divide both sides by 2 and you get x equals 11 over 2. 11 over 2 or 5.5. Now clearly that is the point B. So therefore you've got at B, we've got the coordinate is going to be 11 over 2, 0. And at A, is going to be by symmetry minus 11 over 2. Minus 11 over 2, 0. So when it comes to solving this inequality now, alright, so we can see that if 5 over the mod of x minus 3 is greater than 2, as I said earlier, where is the red graph above the blue graph? And that's going to be for values of x between A and the asymptote here, and between the asymptote here and B. It's these branches of the red graph that we're interested in. So if 5 over the mod of x minus 3 is greater than 2, then we can see that x has to lie between the x coordinate of A, which is minus 11 over 2, and the x coordinate of the asymptote here, minus 3, or x has to lie between the asymptote here, x equals 3, and the x coordinate at B, which will be 11 over 2. Alright, so let's give you some idea of the graphical way that we can go about solving this particular modulus-based inequality. But we certainly can't go about multiplying both sides by the mod of x minus 3, purely because for some values of x, this is going to be a negative value. And it would mean that we would have to reverse the inequality sign. Alright.